Hi, my name is Amin Maramai. Thanks for joining this audio slide presentation of my paper, A Network-Aware Method for Reducing the Average Test Completion Time of Data-Intensive Applications in Cloud Data Centers. The motivation for this paper is that one of the main applications of cloud computing is the running of data-intensive applications, usually consisting of a set of tasks. Cloud computing is a suitable environment for this type of tasks because it provides unlimited storage. In addition, each of these tasks can be performed by a virtual machine. Based on current VM placement policies, it can be seen that data are stored optionally and can be distributed in all of a storage cloud or even on multiple clouds. This causes difficulties in accessing the relevant data that is placed at a far and unnecessary distance. So the file transmission time has a great effect on effectiveness of applications. For this reason, I proposed the VM placement method that places VMs with the minimal access time to the data, and with the scheduling of processing cores for each task, it decreases the running time of this application. In this paper, the files that distributed in the cloud can be indicated by matrix E sub n, and the network status determined by matrix S sub ij. The access time matrix T sub ij shows the access time of each relevant data from VMs. This matrix can be calculated by multiplying these two matrices. As the figure shows, the VM placement algorithm presented in this paper acts according to the following pseudocode. For placement, it traverses all of the columns in the matrix T to find the minimum T and then allocates it. We should also know that after the placement of VMs, the available resources of hosts should be updated by the following equation. In previous works and also in reference paper, the scheduling of processing cores is one of the factors that has a direct impact on running time of data-intensive tasks not mentioned. So adding a scheduling method to this method can be a considerable improvement in average completion time of the data-intensive tasks. For this reason, I used the time-shared and space-shared scheduling policy at the same time and each one at a separate level. In the time-shared policy, processing cores assign non-exclusively, which means that any amount of available cores divide between the running elements and all of them are running at the same time. But in the space-shared policy, processing cores are allocated exclusively, which means that if there are any other running elements, they should wait in a queue as long as the required resources are free. In the following, the different types of scheduling with these policies are shown. Here, a physical machine with two processing cores receives a request to host two VMs so that each VM needs two cores and they want to run 4 tasks. In the proposed method, after testing other types, we use the time-shared policy for VMs and the space-shared policy for tasks that is marked with the red sign. In this case, each VM gets a time slice of each processing core. Then, this time slice is divided between tasks by the space-shared policy. For evaluation of a proposed method, we should compare it with reference paper 11 so that simulation has been conducted with its defined conditions that are listed below. CloudSIM Simulator, 3 computing center and 3 storage center and 3 files with a size of 3000 megabyte, 9000 megabyte and 6000 megabyte are within them. The number of requested tasks are 5, 10, 15, 20, 25, 30 units respectively. In the following figures, the first needed file is 6000 megabyte and the next one is 9000 megabyte and the last one is 3000 megabyte. And as the simulation results show whenever the amount of files the tasks need increases, the proposed method provides a significant improvement in average completion time compared to the reference paper method. Thanks for your attention.